Hi everybody, this is Eduardo Suarez. On my previous video I showed you how to use the automatic calibration grid frame set utility that is available in iRVision. We saw that in the case that the part is placed on a table, regardless of if this is a fixed mounted camera or a robot mounted camera, the calibration grid frame is going to be a user frame. On this video I will show you the other scenario of the configuration, that is when the part is held by the robot, as in this case, and we want to use the 2D single view vision process to find the position and offset of the workpiece relative to the reference position. The setup for this configuration is going to be as shown in this work cell. We're going to have the part that's going to be brought to position on a conveyor. We're going to pick up the part with the robot. We're going to bring it up to the vision system to detect the offset, and we're going to correct the offset to place the part on a table always in the same position. For the case, depending on the process, you can have the camera on top of the part facing down, as I'm showing it here, or you can have the camera upside down looking from underneath the part, or having the camera horizontally looking from one side, whatever is more convenient for you. If we look at the pictures from my previous video, we saw that if the part is located on a table, we're going to have a calibration grid frame that is going to be a user frame, that is regardless of if we're using a fixed mounted camera or a robot mounted camera. And the offset frame, where the offset data is going to be applied, is also going to be a user frame. On the other hand, if we have the part mounted on the element tool of the robot, the calibration grid frame is going to be a user tool that also is regardless of if we're using a fixed mounted camera or a robot mounted camera. For the configuration, you can have a robot mounted camera if a second robot is holding the camera, but in this case, for the purpose of the camera calibration, it's going to be treated exactly the same as if it is a fixed mounted camera. Also, the offset frame, where the offset data is going to be applied, is going to be a user tool. What I'm going to show you now is two different ways to set the calibration grid frame. One way is going to be using the touch-up method, where we set the user tool using the 6-point method, and the other way is using the automatic calibration grid frame set. That is, as I mentioned in the past video, this automatic process is going to be more accurate than the touch-up method, because we are not relying on our ability to touch up the points, and we're letting the robot to find the user tool using the built-in utilities that already exist in iRVision. We're going to start showing you first the touch-up method. We're going to use user tool number 3. In this case, I have already installed a calibration grid on the errand tooling. We have to make sure that the calibration grid is properly secure and is not going to move during the calibration. And the position of the calibration grid relative to the errand tooling can be arbitrary, but for convenience, you want to make sure that the calibration grid is on a plane parallel to the plane where the workpiece is going to be located. And we also want to make sure that the vision line of the camera is going to be perpendicular to the calibration grid. In the case that you cannot mount the camera in a way that the vision line is going to be perpendicular to the calibration grid, the perspective calibration still is going to work, but it's not going to be as precise as if we mount the camera perpendicular to the calibration grid. We're going to have a pointer that is going to be secure on a stand, that is going to be in a position that is also completely arbitrary, and we're going to use the pointer to teach the touch-up points. We're going to open the teach pendant, We're going to select menu, we're going to select setup, frames, and we're going to select tool frames. In the case that tool frame is not showing, you're going to select others and we're going to select tool frames. From tool frames, we're going to select tool frame number 3 and we're going to press detail. On details, you're going to press method and you want to select the 6-point method that is going to be either Z or XY. I'll show you here the calibration grid, and these are the points that we're going to teach. We're going to teach the approach points. We're going to have 3 points, and the approach point is going to be on the origin, on the white point that we have on the center of the calibration grid. For the approach points 1, 2, and 3, we want to make sure that each approach point is going to be 90 degrees or as close as 90 degrees possible, one from the other one. Then we're going to teach the origin, we're going to teach the X direction point, and we're going to teach the Y direction point of the Z direction point. The difference between using the Y direction of the Z direction is going to be when we rotate the grid on a 90-degree angle on the x-axis. So now, if we go back to the teach pendant, in this case I'm going to use the 6-point with the x-y axis. And I have already here the user tool already taught, just to save some time. And I want to show you how this was done. So we're going to start with the approach point number 1. And in this case, what I'm going to do, I'm going to press Shift and I'm going to move to. And you're going to see here, if we zoom in, I'm going to take this one off. If we zoom in, you can see that we have the pointer on the white point, on the big black point on the center of the calibration grid, and we are perpendicular to the calibration grid. So when you are in this position, what you want to do, you want to press Shift and record, and it's going to be shown as used. Next, we're going to go to the approach point number 2. In my case, I'm going to move to that point. And you can see here that what I did, I moved the calibration grid and I tried to move as much as I can in a 90-degree angles from the previous approach point. In this case, I cannot go further because I'm just on the limit of the angle for the axis number 5. So what we're going to do, again, we're going to press Shift and record. And then we're going to move to the next approach point number 3. That is going to be in another 90-degree angles from the 2 previous points. I'm going to move to that point. And you can see here that what I did, I moved the axis, would be the axis number 4, in such a way that we have another orientation for the calibration grid. But still, we are on the same point in the center of the calibration grid. So what we're going to do, when we are in this point, we're going to press Shift and record. Now, for the other points, we're going to go to the origin. And the origin is going to be this point over here. We're going to touch up that point, we're going to move to the X direction. The X direction is going to be on the same direction as the three big dots that we have on the center of the calibration grid, and it's going to be the point over here. We're going to touch at that point, and finally we have to go in the Y direction, and the Y direction is going to be on the opposite side, on the same direction as we have for the two black big points on the calibration grid. So we're going to touch at that point, and in that way we have all the user tool using the 6-point method, and the result is going to be the one that is showing here. So this is going to be the center of the user tool, number 3. I'm going to show you now the automatic calibration grid frame setting. For that, I remove the pointer and the stand. We don't need that anymore. And I brought back the camera field of view. We're going to select user tool number 2. You're going to see here that I have the calibration grid installed in the same position as we did for the user tool number 3. And we're going to move the calibration grid to the camera position. We're going to move the robot to the home position. We're going to select in here the position register number 1. And now what I'm going to do, I just want to move the grid to be on the field of view of the camera, as we're showing here. So now we're going to select in here, we're going to go to menu, iRVision, Vision Utilities, and we're going to select automatic grid frame setting. Over here, we're going to go through the same process again. We're going to select the robot group number. It's going to be number 1. For the set user frame or user tool, we're going to select user tool. We're going to select the tool frame number to be set. In this case, it's going to be the user tool number 2. We're going to select the camera. We are now going to look at the exposure time. For the start position record, we're going to set this position over here. So we're going to press Shift Record. We're going to select the grid spacing, that's going to be 30 millimeters. And the next step is going to be just execute. We have two things that we can do in here. If we select display image, it's going to show you in here the vision, as the camera is looking on the field of view. So this is going to be very handy if you are using the teach pendant, and you can press in here and see in live view. The other thing that we can do, we can go here over next and select the move limits. And the move limits, you can change these settings if you think that the robot is moving beyond the limits or it's going to be hitting something else. You can just change these default values. So what we're going to do now, we're going to execute this one. So we're going to press Shift and execute. And the robot is going to start moving, and you can see here the field of view of the camera. So the frame has been updated, and we can press OK. And we're going to see here the result for the user tool number 2. What we can do now, we can compare the result from the user tool number 2 with the user tool number 3. So we're gonna go to menu, setup, frames. You can see that they are very similar, but if you ask me, I would trust more the automatic reframing than using the manual touch-up. So what we're gonna do, we're gonna use the user tool number 2 for the camera calibration. So the next step is gonna be just go into the camera calibration. We're gonna select robot, we're gonna select Internet Explorer, and we're gonna repeat the same process again. But I'm gonna show you here the small difference that we're gonna have between the user frame and the user tool. We're gonna select create, we're gonna give it a name, and we're gonna select 2D camera, and we're gonna press OK. We're gonna select edit, and we are in the camera setting. So again, the first thing is gonna be selecting the camera, and here we can select the, if it's a raw model camera, we're gonna select no, and we're gonna skip these steps, and we're gonna select for calibration the grid pattern calibration. One important thing in here is that if you come over here, you're gonna see there is display center line we can select, and this is gonna show you where the points are, and it's a good practice if you put the calibration grid in such a way that we have the center line aligned with the center of the calibration grid. So just in the case, in the future, someone bumps the camera moves, we replace the camera, we don't need to do the calibration setting again. The only thing that you have to do is just go in live view, select this center line, and align the camera in such a way that you're going to see the calibration grid again, and that's all that you have to do. So for that, we're going to bring up the teach panel again. We're going to select the data, we're going to select position registers, and we're going to teach the position register number 2. That's going to be the calibration position 1 as this position. We're going to press shift, and we're going to press record. One more thing we're going to do, we're going to teach the same position for position register number 3, shift record, and what we're going to do, we're going to move the z-axis by 100 millimeters. So we're going to select position, and on the z-axis that says 994.8 millimeters, we're going to move it 100 millimeters. Okay, so now we're going to go back to the camera calibration. We have these points already set up, and we're going to use that later. The next thing is going to be, we're going to go to the calibration setup for the robot to be offset. It's going to be this robot in group 1, the application frame. The application frame is going to be the user frame, and we're going to select the user frame number 0, that's going to be world. The grid spacing is going to be 30 millimeters. And what it says here, robot health calibration grid, we are going to select yes. And this is one of the differences that we have between the previous video, when we have the camera on the robot and we have the calibration grid on the table. In this case, it's going to be just the opposite way. We're going to have the robot holding the calibration grid. You're going to see that its settings change now. and it says the robot holding the grid is going to be this robot on group 1, and the setting calibration grid position method is going to be use frame. We're going to select the calibration grid location. For the calibration grid frame, is showing in here the user tool instead of the user frame, and we're going to select the user tool number 2. For calibration grid position status, we don't need to do anything. If we press set, nothing is going to happen. You're going to notice in here, if you select the bullet information button in here, it says this item can be set only when no is selected in robot health calibration grid. So now we're going to go to calibration, and the number of planes, we're going to select 2 planes, and we're going to select the first plane. So for the first plane, we are already in that position. If we go to the work cell, we're already there. So we're going to just take a snapshot, and we're going to set find 1. We're going to move the control points, and we're going to press OK. Now for the second plane, we're going to move the calibration grid. So we're going to bring the pitch pendant, and we're going to select the position register number 3, and we're going to move to that position. Now, again, before we press the Find To, we need to take a new snapshot. You see that we are closer now, and we're going to press Find To, and we're going to move again the control points. We're going to press OK, and we have the calibration already done. We can go to the calibration points, and we can review all the points, and we can see here that we have all the points in green, and the error is also minimum. We're going to do the same for the plane number 2. So we can see here the calibration result. We're going to have again the focal distance, the standoff distance. We're going to have the scale in millimeters per pixel. We're going to have the position of the camera related to the calibration grid. And we're going to have in here the position of the calibration grid relative to the application user frame. We can review this data. We're going to have on the X 1628.8, on the Y 631, on the Z axis 994. If we go back to the work cell, these are the numbers that we're going to have from the center of the calibration grid, that is going to be our user tool, to the bottom of the robot. Again, we're going to save the edit, and we're going to exit. So now the next step is going to be creating the vision process. We're going to give it a name, and we're going to select the 2D single view vision process. So now we're going to edit, and what we need to do, we need to remove the grid, and we need to bring the part. So for that, what we're going to do, we're going to select the user tool number 1, and in here we're going to have our gripper that is going to be a suction cap that's going to pick and it's going to hold the part. On the work cell, I have 2 user frames already created. I have a user frame number 1 that's going to be on the conveyor, and I have a user frame number 2 that's going to be on the table. We're going to start by picking up the part from the conveyor. For that, I have a program already created. We're going to select the main, and we're going to move by step by step. We're going to go to the home position, we're going to go to approach position over there, and we're going to call the program for pick. We're going to change to the user frame number 1. We're going to pick up the part. We're going to wait until we get the suction cap, and we're going to go back to the retrieve position, and we're going to go back to the main program. From the main program, we're going to select again the user frame number 0. We're going to go to home, and from home, we're going to go to the vision position. We're going to call the program vision, and in here, we're going to move to the position number 1. That's going to be on the vision position. One thing that you're going to notice that my position number 1 is on the same plane as the calibration plane that we use for calibrating the camera. So in this case, my Z height is going to be 0. We're going to go back to the vision process. We're going to select the parent tool. We're going to select camera, and we're going to select camera 1. Number to find is going to be 1. For offset mode, we're going to select tool offset instead of fixed frame offset. And now the offset frame is going to be a user tool, and we're going to select the user tool number 1. We're not going to make any changes to these settings, and for image login mode, we're going to select do not log. We're going to go to the snap tool, and now we're going to select the snap window. We don't want to see all the background that we have in here, so we want to change the window to look only at the part. We're going to go now to the GPM locator tool, and we're going to train the part. We're going to select teach, and we're going to move the window to find the part. For the set origin, we're going to move the origin to the edge of the part. And for the elasticity, we want to change the elasticity to 3 pixels. And then we're going to go to the degree of freedom, and we're going to change the orientation. We can probably go from -15 to +15 degrees. And now we can go to the offset data calculation and put in here the part Z height is going to be 0 because the part is on the same plane as the calibration grid. And now we can press set for the reference position status. We're going to have the reference X, Y, and the orientation. Now we can press save and end the edit. We can go back now to the work cell and continue running the program. Now we have the part on the reference position. So when we run the vision process and we get the offset is going to be 0. We can look at the vision register. We're going to go to vision register, and we're going to select the vision register number 1. Now it's blank because we haven't run the offset yet. So we're going to go back to the program and continue running the program. We call the vision process, and now we're going to call the offset. And we see here that the offset is 0. We're going to go back to the main program, and now we're going to go to place the part. So when we place the part, what we want to do, the reference position is going to be such that the edge of the part is going to be aligned with the edge of the table. We want to go to the approach position. We want to call the program for place. We want to change to the user frame number 2. We want to move to the approach position on the table, and we want to place the part on the table with the vision offset. We're going to go back to the approach position, and we're going to go back to the main program. We want to change to the user frame number 0, and we are going to go back to the home position. So now what we want to do, we want to change the position of the part on the gripper and find the new offset and see if it's able to correct the offset. We want to select the gripper, and we're going to edit that. So we can select, for example, plus 10 degrees, and we can move it 10 millimeters. With this new offset, we want to run the program again, and we're going to start from step 17, going to the vision process and placing the part on the table. We're going to get the offset, and you can see now that the offset is with an orientation of 10 degrees. We're going to go to place the part on the table, and it still is able to place the part properly with the edge of the part on the edge of the table. We're going to repeat the same process again, and this time we can move on the other way. So we can go minus, let's try it minus 20 millimeters, and over here we're going to go to 82 degrees. We can see the offset now has a orientation of minus 8 degrees. And when you place the part, you place the part properly on the table. In conclusion, between the previous video and today, we saw the 4 configurations that we can have for the 2D single view vision process. One configuration can be as shown on the left picture, with a part on a table. For this case, the camera can be a fixed mounted camera or a raw mounted camera. We're going to have a calibration grid frame and an offset frame that both are going to be user frames. The second configuration can be as shown on the right picture, with a part held by the robot. For this case, the camera can be a fixed mounted camera or a raw mounted camera. For the case of a raw mounted camera, the camera is going to be held on a second robot. but still it's going to be treated in the same way as a fixed mounted camera. I show you that we're going to have a calibration grid frame and an offset frame, that both are going to be tool frames instead of user frames. Also, in both configurations, I show you how to do the automatic calibration grid frame setting, and I show you how to apply the full workflow from the camera calibration to the vision process, and we look at two applications that show how the offset data is applied. Finally, I'm going to leave the link to the work cell on the description below.